So this is the velocity that it gives us on the question, and this is the time at like time 0, it's 0. That's the time it gives us, and this is what we're looking for at what time 3. So to solve x of 3, you have to make it equal to x of 0 plus the integral from 0 to 3 of x prime t dt. So x of 3 equals, so from here x of 0 is 0 plus 3 to 0, and x prime of t equals that part, so that's t squared plus 6t plus 5 dt. Then you plug this into your calculator, then after you do that, you should get x of 3 equals 51. And then you solve y of 3 equals y of 0 plus 0 to 3 y prime t dt. Then y of 3 equals 0 plus integral of 3 to 0 of t to the 4 dt. Y of 3, after you plug this into your calculator, you should get 48.6. So then P of 3 equals 51 and 48.6.
So we're given the problem that the velocity vector is t squared plus e to the 1/10 t, and then cosine 2t plus t. And then we're also given that at p of 0 the vector is 404 and then 42. And they're asking us to solve for the velocity vector at p of 10. So the velocity vector would be x of 10 and then y of 10. So to solve for x of 10, we know what x of 0 is. We do x of 0 plus 0 to 10 of x prime of t dt. X prime of t is this part right here. We can rewrite this as 404 plus 0 to 10 of t squared plus e to the 1/10 t dt. And then after you plug this into your calculator tell you that x of 10 will equal 754.516. I can do the same thing for y of 10. So that will equal y of 0 plus the integral of 0 to 10 of y prime of t. Y of 0 would be this part, and y prime of 10 would be cosine 2t plus t. So then we get 42 plus the integral of 0 to 10 of cosine 2t plus t dt. And once you plug this into your calculator, you'll get that y of 10 equals 92.456. So then the vector at p of 10 will equal 754.516, 92.456.
So in a problem given that the velocity is sine t plus cosine t for dx over dt, and dy dt would be with t times e to the t, and we start at 0 seconds and we're ending at 3 seconds. And knowing that the integral speed equals distance, we can solve a problem, which would be distance equals the integral from 0 to 3, and like we square root the whole thing, and we have the dt at the end. Let's make sure it'd be dx dt squared, which is a sine t plus cosine t, and plus dy over dt squared, which is the t times e to t squared. And we will plug this into a calculator since this is a hard problem. And you get the answer of 42.0616. And that's your answer.
So in this problem, we're given that r equals 3 theta cosine root theta, and it's on the interval from 0 to pi over 2 all of that squared. So the equation to find the area within a polar curve is 0.5 times the integral of the two limits of r of theta squared d theta. So we know what r of theta is, and we know the two limits, which is 0 and pi over 2 all the squared. So we write it as 0.5 equals 0.5 times 0 of pi to pi over 2 squared of 3 theta cosine root theta d theta, and we just plug that into your calculator. The calculator will give you add a squared, and then you get 1.783 as your answer. So we're given that the velocity vector is sine of t squared, and then minus t squared, and then 5t squared minus 8t plus 3. And we're trying to find the speed at t equals 6. The formula for speed is dx dt squared plus dy dt squared. We take the square root of all of that. Then we know dx dt and dy dt, which is given here in the velocity vector. So we can just plug those in and then plug in 6 for t. So we get the square root of sine of 6 squared, and then minus 6 squared plus 5 times 6 squared minus 8 times 6 plus 3 squared. The square root of all that, and you plug it into your calculator, and you get 139.976.
Here we have a problem, and like this is a polar type of problem, and like one equation is 3 cosine sine theta, and the other one is radius is 2, so it makes this circle. So this is the graph that you would get when you graph these two equations. This is a circle graph, so r equals 2, and this elongated shape is this equation. So in this problem, we need to find the area inside the both of the graphs, and which means you have to do like an integral. Like you need to find where graphs intersect, which is intersects when the theta equals 1. So you're gonna have integral from like start to 1. And like you find this area, like which you can just do like 2 squared, which is just 4. And then you have the theta. And like you have to prove half of them. Then you have to like multiply the whole thing by 4 for you have 4 parts. And then you add another integral and you would start from 1 to this point. So pi over 2. So you write like this and you have to write this equation inside and square it. So 3 cosine sine theta, and then you have to square it and put a dx at the end, and your answer, you end up with 11.517.
In the question, it gives you that r equals 5 plus 2 cosine theta on the interval of 0 to 2 pi. So to solve the area in between that, there's a formula, and it is 1/2 integral from a to b of r of theta squared d theta. So if you plug in your terms inside, you get 0 to 2 pi. 5 plus 2 cosine theta squared d. And then you plug this into your calculator, and then after you do that, you would get 84.823. Okay, so from the question, it gives you 2 r's, and one of the r's is sine squared theta, and the other r is cosine theta sine theta. And it tells you to find the area in between 0 and 2 pi, and it gives it an intersection of pi over 4. And then after you graph it in your calculator, you would get this. And then the vertical one is sine squared theta, and the butterfly looking one is cosine theta and sine theta. So to find one of the shaded regions, you would have to do 1/2 integral from 0 to pi over 4 of sine squared theta. So sine squared theta squared d theta plus 1 over 2 pi over 4 to pi over 2 cosine theta sin theta squared d theta. And then because this is only one of the regions, you have to multiply the entire thing by 4 to find the area. And then after you plug this into your calculator, you would get 0.285.
So here in this problem, we need to find the speed at time when the time is 2 seconds. So we given this problem like the derivative of x of t, which is 5t to the third minus 2t squared plus 12. And yt is this 2t squared plus 9t. And we're trying to find the speed. So the speed equation would be square root of derivative of x of t squared plus the derivative of y of t squared. And we're already given the derivative of x of t, and we just need to plug in a 2 for time. Well, we need to find the derivative of this equation. So derivative of y of t equals 4t plus 9. And you plug in 2, so I'll do the y first. Like derivative y is 2 equals. So I'm plugging in my calculator. So for times 2 plus 9, and that equals 17. And then I need to plug in the 2 for derivative x, which is 5 2 to the third minus 2 times 2 squared, which would end up being 8 plus 12, which would result in an answer of 44. So now we need to find a speed cell, which is just plug it in. So 17 squared, which is the answer for this equation, plus 44 squared, and the square root of the whole thing, which I have shown, and you end up with the answer of 47.170 since you round up.
So the question tells us to find the speed of these two equations at t equals 1. And to find the speed, you need to know the formula of dy dt, square root of dy dt squared plus dx dt squared. And then it gives you dy dt, and then it gives you x of t. And to find dx dt, you have to take the derivative of x of t. So the derivative of x of t is 6t plus 5. And then you plug it in. Then after you plugged it in, remember it tells you to find it at t equals 1. So you just plug that in. And then you should plug this into your calculator. And then after you do that, you would get 16.568.